very well successfully in the last session. So today we stopped at manipulating data and transforming data. Today we want to look a bit of data visualization in R, basic plots, the bar plots, the line plots, the scatter plots, histograms. Those are the basic plots. And also look into the customizing these plots, like if you want to change the title, the labels, the colors, how do you go about that? And if time allow, we finish with some descriptive statistics to get the mean, median, variance, etc. And hopefully the t-test, ANOVA, correlation, chi-square, and the rest. So that will mark the end of the basic training, like the basic R training, so that the next session we'll be meeting will hopefully now start handling the intermediate level as we progressively move into advance, which is the final. So by the end of today, we'll actually have 10 more sessions to go, because we will have done 3 sessions and then 2 sessions practical. That is 5 sessions. So the practical is in the class. I think those who have just joined, you can see the practical is in the class. I'll walk you through how to access the class practical, and then how do you upload your work for marking. So we are also able to look into the interfaces, the 4 main areas of R. Phase, the R Studio, and that is from the source editor to the console pane to environment, history, and the bottom where we have the files and plots. So we are able to do that, and then we began data wrangling, how to create and work with different structures, and we understood 3 main structures, that is the logic aspect, the character, and the numeric. And of course, the very first day, we were able to create the numbers, the names, and review the results. And understood the difference between the vector, which is one-dimensional, and then the matrices. And then last on Tuesday, we were able to import data, which is also shared in the class for those who don't have that data. And I demonstrated to us how you can use the Read Excel platform to actually read the data if it is in XLS, or use the read.csv to actually upload the data. And we demonstrated this. As somebody tried applying this and uploaded data successfully into R. Who has tried by just putting the command? These are the commands here. As somebody, without going through the normal and the manual, like go to the browse and then get the data, and then has somebody tried this?
I've just done it through the other way. I've not tried using the functions.
Okay, yeah. But the function is also very nice, because with the function, you just install the read Excel and then do the library of that package. And then you just write data. The data represent the data frame. Like, how do you want to call that data? Maybe I want to call it data 1, data 2. That's why you see here we have data. And then the sign, which is the left angle symbol, and then you write the command read underscore Excel, and then you go and copy the path where that data is. So if that data is also in different Excel sheets, you can instruct which sheet you want. Maybe the sheet is also not named as sheet 2 or sheet 3. Maybe the sheet is named with another name. You just instruct and then the R will pull it for you. We were able to do that and then to explore some structures of that data. We did some basic summary, like the 5-number output summary, the minimum, maximum, median, mean, and the observations. We were able to see basic box plot and also the histogram. So that's where we stopped. We stopped here actually, where we were now applying the 5 rule, the 5 key manipulating and transforming of data. And we said if you want to manipulate and transform data, the common library which is key is called the DPLYR library, DPLYR. So once you have this once you have the DPLYR loaded, then you can now, is the one that help a lot in, and the function of mutate is the one that help now to transform. And I mentioned that there are the 5 you see here are the main ones in any form of a data analysis. You can either decide to select data, like just giving a condition, I need people who are age 30 years and above. Then you use the subset command, data filtered, and then the subset command, and you are able to, we were able to demonstrate this. Then the another selecting data can be now combining rules like the logical operators and or not equals to, and these are the symbols in R. So we were able to even use the subset again, more than 45 years, but education is secondary form. And we looked at this and it worked successfully. Then the next way of wrangling data and transforming is either to generate a new variable. And I said, when you want to generate a new variable, the DPLYR package is key, and the mutate function. So if you have data like you want to know the BMI and you have weight and height, then you can just mutate the BMI is equals weight divided by height squared. But now in the data we are using as an example, we don't have BMI. That's why we now use mutate age 2, and now we want to see the age more than 30 years. And if you use if else, means it's only 2 logic. If one logic is already taken, like the age is more than 30, you don't need to put another logic and the other group less than 30. So you just leave it, but then you just label it. We're able to see that. And where we kind of stopped, but also you are to figure out, was renaming the variable, which we said you use the names function, change the variable names. Like I want to change the first column of the first column in that data. I want to change it to HHID capital. Then you just write names into the data and then you indicate the column number. One thing you will note that R is very sensitive to comma, and also how this, if you see the reason why this was not working last time, this is like opening, how do you call this ones? Eric, how do you call this? Opening what? This speech.
Opening speech mark, huh?
Yes, so you see this one is opening speech mark, but the what is closing it is not really closing speech mark. If you see this thing, it's looking different. You can zoom, yeah. So that's why the code could not run. And I told you to fix, to find out. I put it there intentionally. I don't know whether somebody diagnosed it. Then we were to label the variable now. We use the labeled package, library labeled. And then I want to label age, for example, label age from, and the reason why this also was not working, you can see the opening speech symbols here are different. So they have to be very similar, alike. If it is opening, then you use the right one of closing. So when you apply this, you are able to actually rename age, not name age, but label age into age in years. we're able to do that, and then reorganizing data. Like now, I want to reorganize data. You use the arrange function. Want to arrange data if age. I want to arrange by age, but also descending what access. So by age is ascending, and then what access is descending. So you're just arranging or data. That is reorganizing. So we have the ACRR and C, very, very critical. The ACRRC is in an analysis. These are what you'll be doing. You'll either select a portion of data, you'll either create a new data, you'll either rename the data, you'll either reorganize the data, or you'll either merge the data. And I said for merging is the easiest because you just write the merge data and use the function merge. And then you put your data one, data two by, then whatever unique code, you must put the unique ID which you want to merge it. So we stopped there, and you are to actually do some practicals, which I want to like explain briefly. Then we continue with the session. Today's session is short. It won't take so much time. So if you go to class, I don't know how many people have logged in already. I see Ibrahim and the rest. If you come to class here, this is the class where we are doing the training. So everybody is just, you don't even need to get, we are not using the link. We are just using the class. You join the class. So if you come, there's this button called stream. Then you join here. You use the button join. You'll just join the class. And an announcement posted here will be posted through here. When announcement is posted, it comes automatically to your emails. And then these are some of the announcements I want to believe all of us have found. There is the practical data, which we are using. If you don't have it, you can download it. We are having our class begins in 10 minutes. Please take note of our class today. All these announcements are automatic. So you can see session 2 assignment. It was use the head and string functions to explore the first few rows and the structures of data set. You are able to learn this, which I know you are able to see, and create a histogram to visualize age in a data set and add a title. Today we are going to add a title and labels so that you are able to complete this. Use the subsets. This is like now the filtering of data. Use the subset function to filter the data and extract only rows where treatment is controlled, which is, you have seen that. Calculate the mean, median, IQR for this variable. Use appropriate R functions. Rename the variable diarrhea self-outcome to diarrhea outcome. You have seen how we do the renaming. Use the names function introduced in the class. Create a new variable called age that bins the ages into 20, 20 to 30, 30 to 40, 40 plus. We stopped here. I'm picking this shortly. Use if else and any other relevant function. Reorder the variables in the data set so that discrete variables like treatment, implement come first, and then demographic like age, water, use the arrange functions. Then the do variable as categorical text like this. Create a new factor variable, education level, that simplify this to only 2 levels, less than secondary, secondary or higher. Use factor. Then the health access and water access variable are measured in minutes. Convert them to new variable, measured in hours. Then create a bar plot to visualize the counts of frequencies. So these are what the assignments for session 2. For session 1, the assignment were attached here. So you do, once you are done, you go to, if there is any classwork, it will be posted here. You go to your, I don't know what you are able to see from your end. If it is Ibrahim, for example, you go there, and then you can I want to show you how to upload the assignment. You go to the grades, and then I don't know what you are able to see. I hope if you're in grades, you can create the assignment and upload it. You can even upload the assignment here once it is written in R. Then it will be graded. And that's how to maneuver all this. It's over 100. So once you upload, it will be graded from this portal, and you'll be able to see your marks. So those practical will help us to gain and to continue. So I think I've illustrated. Is there somebody who have a question on that section? If not, we can go back to our class today. So today we hope to finish the session. If we don't, we'll pick it up again next time, and then we'll do the evaluation soon. So for today, I want to revisit the category called how to create a age category. It's not in this slide, it's in this slide. Like we have just seen how to create age category of 2 variables. What about if you want 4 categories or 5? So you continue to use the dplyr. That is the most important function in R. It does so many things. So you load that library, and then once you load the dplyr library, then you create a new variable. I'm calling it age. So this one is created using a factor. And of course, we use the mutate functions, which is typically for manipulation and transformation in R. So the data I'm creating is, maybe I'm calling it data. The data frame, I'm calling it data. And then you use the mutate function, which is the one with the ability to create a new variable. Then the data I'm pulling from is called data, maybe data X or data 2. Then the variable I want to create is called age group. And then because this is a factor, meaning is it has categories. So you use age group is equals to factor. Age group is equals factor, which means it has a category. And then the category itself is now cut. So what I'm putting to cut here is the age. It takes the variable presumably containing the numerical age. So I'm putting the categories for the variable age, and I wanted to have breaks in that infinity, that is before group 20, you use hyphen negative infinity. And then after, then I want the age 20 to 2024, that is inclusive group. And then now whatever comes after 24, that is infinity also, which is positive. So that's why you can see. Then you label the categories as less than 20. That's why we have infinity negative, and then inclusive 20 to 24. And then infinity positive is now 25 and above. And you ordered means is from lower to largest. So I'm making it ordered in that it arranges from small to largest. And that's why I use the command ordered is equals to. So when you run this in R, you should be able to get age categories. So just to re-explain again the functions, that mutate is a function from the dplyr package, and it is the one which is helping in manipulation in R, like transformation. So when you want to create a new variable, you use the mutate function, and then create the variable name, creating age group, and then the factor, we are using factor because what we are creating is a categorical variable. It involves 2, 3, 4 categories. So that's why we use the factor function. And then we, of course, take the cut functions output, like converts into a factor. For example, this function will play a very crucial role in defining the age categories. So cut, if you don't put cut, probably it won't define the age category. So that's why the cut, which is factor into cut into. factor into, cut into. So that will help you to create those categories. And then the breaks, it defines the cut points like infinity, negative, and then inclusive group, and then the infinity positive, like represented by the above 25. All that I've explained, it helped to put it in natural order, like less than 20 comes before 20 to 24, and then so on. So when you run this now to R, that code, we are, let me open our R. You also have your R from your end. We are just building it up from where we left. So, okay. So, session 3. Good. So when you run this in R, I'm using the data, track data, the data you have. So the data you have is what I'm using. So when you run this in R, today I'm running so that we save time. I think I need to attach the data. We have the track data here. Okay. Okay, mutate. Okay. So we need to do the function again. Okay. Okay, let me just run this so that it's read in the. Have I changed the data? Okay. So those are headings we are able to use. Tail, string. We are able to use type of. We are able. These are what we explored. You can see the histogram. Those are what we did last time. Okay. Okay. So I want to reach where we are now doing the age category. So that is where we did the two groups, the two less than 30 and more than 30. Good. Label the variable. Good. So today we are here. Yeah. Yeah. So you see, I've already created the age category. So you can see this data by just view, so that we see data run. So we should be able to see that age category into 3. It is here, the last column. The last column, you see, you can see it is 25 plus 20 to 24, the less than 20. Yeah, so that, yeah, less than 20 I've seen around. Yeah, so that's how to create the age category. You just use the mutate and then mutate your data, what you are creating. Then this is a factor function, and then cut limits, age, and then infinity, like before that 20 to 2024. That means less than 20, and then inclusive 20 to 24. And then infinity positive beyond 25 or 25 and above, and then ordered so that the smaller comes first. And that will create that. And you have viewed, you have seen the view of the data. Then the next today, so that's what we did last time. So for today, we want to look into data applications, visualization in R, like seeing how do we plot basic plots like bar plots and scatter. So there are two things. There is the very basic, and then there's the customized. Like now the customized is where now you are making it more beautiful. You are adding label, color. You are just customizing those the plots, but the basic one. So when you see bar plot, they are very ideal for visualizing any categorical data and comparing the counts and frequency. Like the age category we have just put, it will, the bar plot can give you very nice visuals about that categorical data. So from basic, you just say bar plot, then the age category counts, for instance, and then the distribution is of age categories, and then so it has both Y and X. So our X X line can have the age category, and then the Y, as the vertical line, can have the count of those. So that's very, very basic, and you can see it here. When we go back to state R, you can see we are creating the data frame is data, and then the group we are creating is age group. So always remember to attach it to a data frame. If you don't attach it to a data frame, it may not create. That's why we are linking data and then the group. So, and this is a data frame we are creating. So we have a data frame called data. We are also creating a data frame called data category counts. So this is kind of a very basic plot that we want to create. So bar plot function, then the whatever we have created here, and then you just label, let the main be the distribution of age categories, and then the x-axis is the age category, and the y-lab is the count, so that you see this very basic. It doesn't look nice, it is dark, you can see. It has counts of these people, this data adds so many people, distribution of age category as our main heading. What we are calling main is the distribution, and then the age category as our X lab. And then the Y lab has the counts. That's why you can see here's the count. So you can see majority is actually 25 plus 2024, and then yeah, less than. But then if you want to make it now beautiful, like from basic bar plot to now a more colorful. We said one of the reasons why we champion for R is R has a very nice visuals. So now you use a function called, you install a library called ggplot. So the moment you see ggplot, ggplot2, this one will help you to give you very nice visuals. So you have to load this package, ggplot2, for visualization. So remember now we have tdvars, we have dplyr, we are now seeing ggplot here, we are seeing mutate functions. So those libraries, especially libraries like ggplot, label, we had seen library for labeling, those ones you can install very fast before you start running the data, because it will help you somewhere. So we have ggplot, and then once you loaded the ggplot, you just now do ggplot as the command, and then the data of reference, then the AES is also another function. And whereas we were seeing in simple bar plot, what is your x-axis? So your x will be the age group. In this case, we are calling it the X lab in the simple bar plot. X will be the age group. Then the Y, if we have counts, fine. If we don't have, Y will be also the Y lab count, like what counts that age group. So Y will be the same thing. And then now you want to fill it. You want to fill this graph by age group. And now these are now the beauty. The beauty starts from the geom bar. Geom bar is what defines a bar graph. Is the command that reads a bar graph. If you do line graph, it is called geom line. Geom line. If you do which else? If you do scatter, is it scatter plot? But yes, for scatter plot, it is called the geom point. Geom point. So those are very key things. So for, if you want, like, I want a bar plot. So the function that will instruct the R that is a bar plot and not any is a geom bar function. And then you specify, for example, statistics is the identity, and do the color. I want sky blue, I want green, yellow, and do the position in terms of the dodging position. I'll explain that. And then, of course, you can customize the back color and position by giving labeling. You label the title, for example, age category for the participants, and the x-axis we had seen is the age category, the y is the number of participants in that age, and then maybe you want to scale the field, the manual, like the specific values now. So less than 20 is light blue, 20 to 24 is blue, 25 plus is dark blue. So that is like more now the beauty of R in visualization. So if we go back to the R interface, then we have seen the very basic, simple, because this is where we all begin. We start from here. As we gain more skills, then we advance. So for example, now, and you can see the beauty of R, it will be highlighting that color here. So if it is not looking well, like I don't like sky blue here, I can say I need it green, then it will change it to green. That's the beauty of R. You see it is now changing to green. If I want yellow, I want it yellow, it will change to yellow. So depending on what you want. So if you run this code, you run the library of the ggplot. That's the first step. And then you run the code, the ggplot into the data of reference, and then the age category, which we have been very interesting. And you can see the output is now looking nice. Age category as the main heading, the number of participants, and then the age category on the x-axis. It's now looking nice, and it will continue to look nice and nice until we will now do some labeling, like mark proportions here. It also has NA, you can see. So, and if you compare this and this other one, is taking the same trend. It's kind of taking, yes, you can see it is taking the same trend. So that is a bar plot in R, the way you can do it. The next one is on the line plot, and line plot as we are seeing now. The beauty, once you have one for bar plot, the only difference is now the geom bar, and then the geom bar, and then the geom line. That's the only difference you will take note, because the function from a bar plot is geom bar, and then the function into bar line, line plot is geom line. So that's what you change. And then the only another thing to take note is a line plot sometimes is good when you are comparing time difference. Like you want to compare time, the change of income over some period of time, then that's when it will work best. In our data, we don't have time elements. So we are just assuming, let's say the PPI.PC underscore PCT 100 is the time aspect. The rest remains. And then the scatter plot is also useful in visualizing relationship between two continuous variables. Like you want to see how is height relating to weight. Does the gain in height leads to decrease in weight? So when you have two continuous variables, then scatter plots can do very nice visuals for you to understand the data. All these are still part of manipulation and transformation because you understand the data in details. Then, of course, histogram, we were able to see this. When you want to see how is the distribution of a continuous variable, we were able to see hist age, and the customized one is now the ggplot, still able to give you this. And now here we use the geom histogram. So those are the things you can take note of. For bar plot, geom bar. For line plot, geom line. For scatter plot is geom point. And for histogram is geom histogram. So those are very critical. And now we can go back to have explained all this, that ggplot and AES is the function that set up that plot. And then the geom bar will define a bar chart. The geom line will define the line plot. The geom point will define the scatter plot. The geom histogram will define the histogram. And then the labs, you see, is basically for labeling the title and the axis. So we can go back now to run the view now. So we have seen the ggplot. We have seen the geom bar, so we can also see the simple line. So I say the disadvantage is that line will work best with the kind of age different time difference. So in this data we don't have a time, that's why it is not looking nice. But now that you can get data with the time, then you can practice and explore. Then the colorful one, you can see the colored one is now showing these edges with the colors. I think the less than 20 is not looking very well. I think I can change it to green or black. Anyway, when you change here, any color you change, it will show you. Then you just run again, and if it is not looking nice, it's even the worst. It's not even appearing. So then the basic scatter plot is that's ggplot data, and I've said you can see relationship between two variables, continuous variables, x, y, and then you can run that, and then you see the scatter plot here. But then you can customize it so that it looks so nice by giving it a heading and the rest. And then the simple histogram is hist. We're able to see simple histogram last time when we just do hist, for example, east age, and this one we saw even last time. It's simple, it's not looking well, but you can make it well now and make it more colorful. And you see with the use of, and then here now it eliminates missing values. So it can tell you 107 rows containing non-finite values has been eliminated. So if you want to change this color to yellow or green, for example, and by the way, these things you don't cram. It will come with practice. You don't cram. Once you do one, you do two, you get fun into R. And then any data now you want to use with R. That's the beauty. You don't need to cram now. How do I cram all this? They look like formula. They look like programming, but it even if you get an error, you just try to figure out, read. There are some resources online you can check, and in the process you keep on learning. The best way is to have a code like now we have a code here. Do develop it on your own. That become your master code. So you are able to use your master code for anything. So when you have a data, it needs renaming, you know how to do renaming. It needs name functions. Creating a new variable, it needs mutate function and DP, LYR function. Labeling, you know that. So that's the beauty of it. Do you have any question there before I move to the second part of the session today? Actually, the second last. I think put your questions so that we'll ask after we are done. Good. So for the next part is basic statistical analysis. This is now very easy. Here we are just trying to describe this data, summarizing the data using measures like mean, median, standard deviation. So there are two main types of statistics, and that is descriptive statistics, just basically to summarize, explore, describe data. And also we have inferential statistics trying to draw conclusion. So in descriptive statistics, if you want to get mean, median, we use summary function. For example, summary function for basic statistics, and this will only pull numeric variables. You know the difference between character, numeric, logical. So when you use a summary, you can use summary, the entire data. you will see summary statistics, the 5-number summary of those numeric variables in the data. But if you want specific, like you just want mean, then mean of age, then you use mean, data frame, then operator, and then age. That will give you specific mean for age. So just to illustrate that, and the 5 summary, I mean minimum, which is the lowest value in that data, the first quality, the first quartile, the middle value, median, the average of all the values, which is the mean, the third quarter, and the maximum. So these are the summaries you'll be able to get. So for example, I want to get summary of the data. The data is here. If you see the environment, we had created this data here. So I run the summary there. And then you are able to see, it pulls out the summary on household ID, ID ward, village, treatment is a character, so no value. Implementation is a character. Diarrhea is a numeric. Percentage 100, you see here. So it gives minimum, first quarter, median, mean, third quarter, and max. And if I just want to see for age alone, then I can do average age, then the mean data, data frame, and then age. So this will give you for age alone. And if you run, it is coming here. If you want to see the results on that, you print the results. It is NA. The reason why it is NA, the data is having some missing values. So it cannot calculate missing values. It cannot calculate a mean of a missing value. So we use the function not applicable .rm to actually ignore. Let me see if I had written. Yeah, it is here. So you use not applicable .rm function, and you say it is true. It's an argument that is passed to the mean function. So when NRM is said to be true, it instructs the function to ignore any values in the input. So it's just telling it that ignore, pass that. That's why now we don't use the mean data frame age. It comes like it's not available. So you use the NA RM to ignore. So when we use that now, then you run, you can see the mean is now 32. And if you see the mean here, where was age? Age was here, yes, and the mean here was also 32. So you see it has just pulled this. The mean is 32, here is also 32. So it helps you to single out. So the same process continue when you want median. You just use the median NRA, because if you use median alone, it won't read. It has some missing values. So to bypass it, you use the median data frame age, and then NRA NA.RM is set to be true. And then you can see the median is 31. So if you come here into age, the median was actually 31. So you just use median, average, use mean, median. When you want variance, you use VAR, that will give you the variance. Then there's also another pack. If you want standard deviation, you use SD function. And all those, if you forget, you come to the help, and then you say, for example, I want something on mean. I've forgotten mean. Then you can see everything there. It will tell you mean. You just type mean, and then you see it even give you NRM false. So this is how to get the commands. Yeah, that's how to get the commands, and you can see all this here. Good. Then standard deviation, you just use SD. But there is also another package called Psych from Psychologist. So this one will try to describe data in details. We'll describe that data in details. But then you have to install the library. You have to install the package called Psych, then run. You install the package, then run the library. That is the procedure. You install the package. Once the package is installed, then you can run the library. So once the library is run, and then now you can describe the data. And you see it is describing the data. And there is error because the package has not installed successfully. So you'll install it, give it time, then you can now run the data. So that is some basic statistics, how to get mean, median, variance, standard deviation, and those are very key summary statistics. And you can see if the data is having missing, you have to give a command like na.rm ignore. So which means it's true. If you put it false, it won't run. And keep summary points. Use summary for a quick overview. Use specific functions like mean, median, variance, standard deviation for individual statistics. You are now interested on individual statistics, then consider Psych for a more detailed report. And lastly, is on some inferential statistics, which again, these are very basics. As I've said, inferential statistics, they use a small sample data to make an inference about the population, like generalization or conclusion by just testing using a sample population to test hypothesis. Then in that case, we apply inferential statistics. And these statistics are very many. They include t-test or independent or paired. So the most important thing is to check the data distribution, as I said last time. If the data is skewed, like in our case, is positively skewed, then you cannot run an independent t-test. In that case, you run Mann-Whitney U-test. If it is, so there are different types of tests based on basic understanding of your data. That's why we do those basic visualization, summary statistics, histograms to check data trend. Here again, you will just apply the function like the t-test function, t-test results. So here I want to leave it for you to try to explore. When we meet next time, we'll do a recap on these functions, the t-test, the paired t-test, the correlation, the ANOVA, and the rest, so that we see if you are able to get something. But also for chi-square, I can do for chi-square, because chi-square is basically categorical variables. We have already created a category on age. We have in that data, there is also a category on treatment. It is either treated in treatment or control. So I can demonstrate that. So when you want to do for chi-square to process, you create what is called a contingency table. And I know George is an epidemiologist. I don't know whether he's in the class today, but 2x2 table, you create that contingency table by putting the variable of interest, and it must be a categorical variable because chi-square is for categories. Then categorical variable attached to a data frame, and then whatever categories you are interested, which is treatment, and then attached to a data frame. So when you create this contingency table, then now you can run the chi-square by just running the chi-skew.test function, and then run that contingency table. And this will give you the findings. Then if you want to see the findings, you print. So you can see the p-value is 0.4004, and the chi-squared value is 1.8, and it is not significant. So, and if you want to see this, you can also print the contingency table. Let me see if we can print the contingency table. So we use print to actually see that result. So you can see the contingency table. Less than 20 is 104. Treatment is 106. 2024 to 81. Treatment was 332. And then if you run this, it is not statistically significant. I see we have taken 8 more minutes because we were, no, actually we are on time. We have 2 minutes to time. So can we get any reaction, any question from the class? Any question? Robert, I see you are here. Okay.
Yes, I'm in too late.
Good. So I think so we don't have some students, but we'll always do a recap, because if they don't follow, then it's a bit tricky. Any question? Are we following? Are we practicing?
Yes, yes. And I have a request.
Ah.
Maybe sometimes during can the notes be shared? So maybe when you are doing practice, you can refer to the notes and see maybe how the functions are written.
Yes.
So from
Yes. That is true.
So from when you are
now like basic, we are actually done with the basic training. So next session we'll because of the class which is not full, that's why we'll do a recap. Otherwise, the next session was actually going to be intermediate level. Now going into deep in the DPLYR function. So what I'll do, I will upload the notes, the presentation in the. I'll upload the presentation in the class. Then you can always practice as you use the presentation. That is the beauty of learning. Just spare some 30 minutes or 1 hour, then learn a concept. You can even learn only creating a variable only, and you say, now I can create a variable successfully. Remember, one of our clients had given us some work in R, and up to now, because I'm the one who was working on it, and I put a hold, and one of the assignments there was to create a variable. So I think I'll send that one as part of assignment. Try to create the variable, and then the next question was also to run chi-square. Then we run and interpret, and that is how we learn. Yeah, so thank you, Francis. Eric, are you there? Any observation? I know this is your second class. You missed a lot, but I've tried to recap.
Yeah. Thank you so much, Japhet. Can you hear me?
Yeah, I think the class is so rich. And as I said, this basic, if you don't mind, could you just stop?
Yeah. This stop. I can even
Recording.
stop. I can even stop at my end. Yeah.
Yes. Yeah. Stop and save those.